midterm exam week, but as I announced, we are going to have the midterm October 21st, but because of this one, for state, so we are going to have midterm exam October 23rd, is a Wednesday. That will cover up to the database programming part. Okay, everything from the beginning to the database programming that we are going to discuss today and the next week. And also project page grid for the SAFE. Also I extend the due date 1 week, that is October 25th. So in the project, so you are going to create you already create the MySQL database and but the web server using the Google App Engine, even though you are using the standalone system for your project, one of the team use, but this is for practice purpose. Okay, I am going to require to create the web server with the Google App Engine because the database exercise will require. So, in case you are going to use a standalone or system setup, should be done by that time. But we are going to have the exercise October 21st, okay? Because just in case we do not have the class the next week Monday, so this time we will cover the database programming part. Then this Wednesday, October 9th, we are going to have the exercise lab for the practice of SQL that we are going to discuss. So next class, on Wednesday, bring your laptop, but your MySQL database on GCP should be running condition. So if you test it before what the start, please be ready before the class begin on the Wednesday. So Wednesday, the DBR will start the database exercise lab right away. Okay, then I think that is the overall thing. So I will let you know by the Wednesday whether we have a class. If there's no announcement or if I forgot, we are going to have a class. Okay? So that's the midterm break is only for the undergraduate student. Any question regarding to the schedule? So today we are going to start the SQL part. So for your reminder, so we almost done from the information. So to create the database using DBMS system. In this method, we are going to use the MySQL database running on GCP Cloud Computing. It doesn't matter. But our main focus of the first semester to design our database. So to do that, we start from the conceptual design. That is based on the ER modeling. So ER modeling, we can create the entity or relationship and other things. So finally, we can organize the information, small organize the information, okay, with the entity and the relationship. However, this is not the database model or the system, the friendly model. So to get close to the system, the database management system, we are going to use the database model. So specifically, we are going to use relational database model that include the relation and the other constraints. Sometimes we have primary key, we have foreign key, we have something other constraint. So it's also the organized structured data, structured information that is close to it's almost ready to be database. So also we have learned how to create such a relational database schema diagram from the ER schema diagram. Then final step is using relational schema model with relational model. We are able to create the database. So to do that, so we need the language. Okay, the computer. This is the computer software, definitely they don't understand this diagram itself. So we are going to use the language, the program languages. So database has the structured query language. Actually, this is based on the relational algebra, relational calculus. So especially we are going to use the relational algebra. So this SQL is basically consists of two parts as we discussed before: data definition language, data manipulation language. Data definition language to create the database structure, like to create the table, create the relation, create something, and or sometimes modify the data structure. On the other hand, data manipulation language is focusing on the data, like the insert, delete, update, and the select the such a data. So today we are going to cover the such a data manipulation language as well as the data definition language. How the good news, the SQL is based on the first relational algebra, which means relational algebra is a foundation. It's proposed by the Dr. E.F. Code. It's already standardized. So SQL, if you know the SQL on Oracle or the MySQL, so that means you are able to use the same query language for another DBMS, like the Oracle, Informix, or DB2, because any database management system, they are based on the standard. It's a relational database model. However, not everything, mostly, roughly say the 70–80% of the SQL syntax in any DBMS system are standardized. It's exactly the same. No matter what DBMS you use, it's the same. The other 20–30% are their own feature. Oracle has their own additional. It's an additional feature. And the DB2 has their own additional feature, and MySQL has their additional feature. So if you understand the such a standard, the SQL, command the SQL, so I think there might be no problem to use even other the DBMS system. Okay, so today we are going to see the DBMS. So before we start, we are going to very quickly see the history of the SQL. The SQL, when I learned the database the first time, it's called the SQL. But nowadays the SQL is popular, the pronunciation, so it doesn't matter. SQL, the SQL or database language, the SQL is more popular. And the SQL is actually based on the relational algebra. So when after Dr. E.F. Code proposed, the IBM actually tried to implement his idea as a commercial software. But at that time, the IBM has the most popular database, not database, it's a computer system, which is the mainframe. So mainframe is kind of starting from the centralized system. It includes everything in one server, and even that the IBM mainframe includes the database. It's a hierarchical database. Still hierarchical database is currently used in the commercial system, but it was popular at the time, 1970 and early 1980. So IBM first time tried to implement and commercialize his ideal relational model as a software, but they gave up. So because of that, the popularity of the mainframe and the hierarchical database. So then at that time, so some of the people, like the Reddy, currently CEO of the Oracle, they realized the idea is very good for the commercialized system. So they implement his ideal relational model and the relational algebra as a programming, it's a SQL. Then his released the first version. It's actually not version 1. He started from the version 2 because he believed the version 1 is usually kind of prototype. It's not mature. So he started from the version 2, but the version 3, version 4, but up to the version 6, before the version 6, it was not commercialized. However, from the version 6, it's not only the problem of the quality of his implementation, but with the popularity of the internet and the personal computer, even at that time, the downsizing, as I mentioned before, downsizing with such the changing of the computing environment. So people need the database management system. Then the Oracle version 6 is the almost the first the commercialized version. Is popular for the computing environment. Then IBM realized also. So we need such a relational database management system rather than the hierarchical database. So they start to implement again the relational database, that is the DB2. So DB2 is still the product of the IBM that support the, it's not clearly the characterized, but the most Oracle database is still the half of the 40% of the database market. It's really big. Okay? It's the biggest software company that compete with the Google. So Apple actually the iPod, iPhone, Mac, and such a thing, and Microsoft also the nowadays they produce their own the PC and so on. But Intel definitely is the processor and the chip. The people believe the Oracle is the kind of only one software company that compete with the Google, but because of such a big market share, it's almost 40% entire database market. Think about even the UB or such the small college, they have the database management system. Not always the Oracle, but they use. So, but the market is 40%. Mostly online transaction processing. If the company requires such the online transaction processing, like the financial or the stock market or some requirement that ask a fast response time. At that time, the online trend, the Oracle is popular. DB2 is more like the mid-range, the workstation. Okay, because right now IBM focus on the data analytics. They gave up a lot of hardware part. They no longer pursue the manufacturer, the company. Instead, they declare the IBM is a software company, service company, especially focusing on the machine learning and so on. So before that, the DB2 worked with other IBM computer workstation level. So DB2 is still used for such a middle range, the workstation, the database. And then the MySQL is the open source. Long time the open source, the relational database management system, DBMS, so you can free to use. Still you can free to use, but it's no longer open source. It's a part of right now Oracle. So Oracle owned this one. So MySQL still being used for the if somebody want free the database, the management system, they can still use the free software, but for the maintenance purpose, they need to pay the service fee to the Oracle. So that is the MySQL. So then the Informix is 5-6 years ago that the is merged to the IBM. So still they produce the name of the Informix, the DBMS. That was popular for data warehousing system long time before, like the 10-15 years ago. So data warehousing, Informix was good, the database management system. Plus we have the SQL Server, so Microsoft the SQL Server. So just like the Windows, so Windows, when the Bill Gates implemented first operating system, do you think he developed the entire kernel for the Windows? Actually, he started with the DOS. So on top of that, DOS is, anyone who knows the DOS? It's operating system, command line operating system. It's the old one. It's not that the Microsoft gave up the DOS as a part of the operating system. So right now it's very similar as the CMD, command line. But the command line CMD is not operating system, it's the interface. But the OS is the operating system itself. So if you are taking the operating system class, you can recognize, you should understand what's the difference, DOS and the command line. As an interface, it's almost the same, copy the file, where the basically operating system can create the manage the process. But this one is not. So this is the DOS. So when I learned the computer first time, 40 years ago, so it started with the DOS. So how to use the copy command, how to use the delete command. It's a part of, each of them is a process, okay? Part of this one. Then the build gate actually build another part of kernel that focus on Windows. So it's not convenient to use the computer system, operating system, because it's a command line. So why not using something graphical user interface that is Windows? Then the Windows, still they use the rectangular shape of the Windows to represent, to show any the interface of what? Process. Eventually, when you learn any kind of program, it will be the process. Then they use the computer resource, CPU, memory, and the file system. That is this one. But this one is also operating system. This one is operating system. What's the big problem? It looks like there are two kings, two gods under the heaven. So that doesn't make sense. So even think about if we have the two professors here, so each of them is different. The philosophy, different approaches, so they cannot work together. So because of that, until the Windows 95, so Windows has really a lot of problems. But still they exist because it's a personal purpose, single user. Okay, this characteristic is still exist in the Windows 10. So do you allow your Windows 10 for other user to log in? Mostly not. Even though it is possible, like the Windows using the what? Remote desktop. You can allow the other user, other people can access your computer, but mostly you don't want. Even you are scared to leave your computer at home, then log in, instead you bring, carry on every time. So such a characteristic still exists. Then even though they throw away this one, because of this characteristic, actually the operating, if you are starting with operating system is not very friendly to the graphical user interface. The graphic is another part. So main part is the processing. The main part of the program, the processor, is the processing the instruction. That is the main part. And the graphical user interface is the outlook. So because of that, Windows has a lot of limitation for development purpose or management purpose. So recently the Windows allow what? The shell. So like the PowerShell is available, and what else? So you can use the Bash shell by installing the development the option. So you can use such the conventional concept of operating system and Windows, but still it's a single user. Same thing for the SQL Server. When they develop their own DBMS, RDBMS, the SQL Server is for single user system. Single user system a lot different from multi-user. Definitely database, as we have seen, is for multi-user, multi-transaction system. So later, the SQL Server, Microsoft realized they need to support the transaction management system to support the multi-user. So they actually purchased the transaction module from the Sybase. So Sybase is currently, I cannot see a lot. So I'm not sure whether it's a still existing company or product or not. I cannot find the additional information. But Sybase is another. It was popular, the relational database management system, but not existing right now. I'm not sure, 100% sure whether it's gone or still exists. But people the researcher or the professor or engineer in relational database community, they believe the Sybase is one of the best, the implementation of the relational model, okay, in terms of architecture. So Microsoft projects a transaction model. Right now, the SQL Server also support. As you can imagine, the Microsoft SQL Server is good for what? Microsoft family, like the .NET environment or the Visual Studio based implementation, such as C#.NET. It's good for the the application and the front end part. Okay, definitely it works very well. So these are the overall overview of the relational database. Then all of these are using the SQL as a language. So they get together a long time ago. It's 1992. The people who are part of such a commercial or the research community, they get together, then they build a standard. That is before that, it's 1980. I think the 1980 first time. Yeah, 1986. 1986, they get together, then they build a standard. It's called the SQL standard. It's the first version of the standard. Then, 92. At this time, actually, frankly speaking, it's not that popular. Nobody cared. But during that time, more and more users use the SQL. They realize the strong, strict standard of the SQL and additional feature. Okay, so they get together, make another standard SQL 2. It's called the SQL 2 standard. So this is the most of the feature of the current SQL. I think the 90%. So the SQL that we are going to discuss today and exercise a lot, mostly based on the SQL 2 standard. Okay. Then later, the 92 is almost a peak time for the downsizing and the 3-tier architecture with the network. Then around the 2000, they get together additional feature like the object-oriented. There was no object-oriented concept at that time. But because our problem is more sophisticated and difficult to design, function is not enough. And such a design, when you understand the object-oriented concept, so why we need the object-oriented concept? OP. Hide
information. So
hide the information. Why do we need to hide? Because the problem is more complicated. We don't have enough time to understand everything. We don't have enough time to implement everything. So if you are not using the OP, so you can just define function every time. But nowadays we need to use a lot of existing library and so on. So our problem is not, so relational database is not object-oriented concept, right? So think about the one example is a person. So if we have the person, we can actually use the definition of person for student. We don't have to worry about the actually attribute of person, just borrow, then define the student by adding the ID and major. But it cannot be done in relational model. So that's the reason that we try to address such thing. Same thing happened in that time. So they need to address some of the feature, like the user-defined function, like the method. Method, no way to implement in SQL, but the people want, I'd like to create my own function, like the method in the object-oriented concept. So they add such an object-oriented concept and additional feature. So that is the SQL 3. Then 2006, people add the XML feature, object-oriented feature. This is the SQL. This is a 1999 and 2006. So it's a new standard. However, from this standard, more and more such a commercial company, they implement and sell such a product. It's a big part of the database community. There's no room for researcher like me. So right now, such a relational database community occupied by the all 100% the commercial vendor company. So they decide from this one standard is not free. Which means I have an idea, I'd like to implement a relational database, the UB, Relational Database Management System, based on this standard. Because it's a standard, like IEEE standard in network and so on, so we can we'd better use such a standard if there exists. So if I want to use this one, I need to pay. Okay. So, but up to this one, it's not. So a lot of the open source database still support up to this standard, old standard, SQL 3 standard, but the new standard, so it's not free. That is one of the biggest problems. Because they already bigger and bigger and the really big the pie, and they have the market share. Do you want, if you entirely replace such idea to object-oriented database or the NoSQL database, the pie is not guaranteed, right? It can be 10%, this one can be the 20%, the new product will be the new market share, right? So they don't want to be risky. Oracle, Informix, IBM, the DB2, they don't want to be risky to replace the basic fundamental of the database. Still, the people use the relational database well, and they pay. Okay, that is the current situation. But so more and more the complaint and the improvement of the database concept, that is overall is a NoSQL database. So NoSQL data, we are not going to discuss about this one, but in the NoSQL database class, we will talk about it. So today, most of the thing is based on the SQL 2 standard. We are not going to cover too much the new feature because this SQL 2 standard is mostly enough to implementation of your model. So your model to the physical database. Okay. Then one more thing is to use the SQL that we will discuss later. There are different ways. So like the Python. When you study your Python, how do you study your Python? What is the programming environment? Some of the people just type the Python, then you can see that this one, and directly code the print or whatever. This is called Python interpreter. Okay, so you can use the Python interpreter. Then, if you have the several command of the Python, you can use script. .py file, called the .py file, run with the Python .py file, right? So it's a script. Basically, it's the script of the Python interpreter. Okay. Then you can have the Python API using your program. So you can use ID like that. So there are different. Similarly, when you learn the SQL, so each DBMS provide their own SQL interpreter. So interpreter is different from the compiler. Okay, main different thing is interpreter is line by line. But on the other hand, the compiler is the entire source. You can compile, translate at one time. So database SQL is an interpreter. So it's a line by line. So for example, Oracle has the SQL plus interpreter. It's just, if you enter the SQL plus, it's like the SQL prompt. It's similar as a Python interpreter. So, and the DB2 has the DB2. MySQL has the MySQL prompt. So we are going to use the MySQL interpreter for practice. Okay? And the SQL Server has each of them. But the Informix is slightly different. Informix has all of them are interpreter, like this one prompt, but this one has a menu driven. There are menu driven, so you can select the table. You can select the multiple table in case of join. You can select the join condition from the list. So like the menu driven. So sometimes I offer the second project for this, in case I have only graduate student. But not this time, so it's a menu driven. But each DBMS. So if you have a chance to use the different DBMS, RDBMS, First check what kind of the interpreter or the programming environment provided. Later, we will see the different, there are third party, like the IDE, third party interpreter or program. It's not, that include the interpreter, okay? But there's a better outlook and the better interface. It's like the IDE. But we cannot say that kind of third party software, IDE, because the database programming is not only SQL. Later, we are going to add other program languages. It's the host program language, then this is called the database program language. So today we are going to see the SQL with during the exercise lab on Wednesday, we are going to use the MySQL interpreter prompt. So that is the overall thing. Then start with any question? One more time. So our schedule slightly changed because of the midterm break, October 14 and 15, but it's only for the undergraduate student. That doesn't mean the undergraduate student can skip this class. I'm going to ask the School of Engineering. I asked them. I'm waiting for the response whether I can keep the class for closed listed or it should be the off next week. So because of this one, for say our midterm exam is October 23rd, the Wednesday, and the exercise lab is this week Wednesday and October 21st. So mostly SQL and the database programming. Because of this one, project due is delayed, extended to the October 25th. So phase 3 requires set up all your system environment for your project. Okay, so when you start any implementation of your database, here, it starts with the database schema. Database schema is like the boundary of your database. Okay, it's kind of boundary. So when you build your house, not house. Let's go back to Western, the age like the 18th century, 17th century. So if you horse riding, then to the end of the day, then you can put the flag. This is my land, like that. Going to west, west. So first time, no matter what you are doing, so you need to decide your area. Okay, this is your property. This is logically your area to create inside. You are going to create the table. You are going to create the index, anything. So if you remember the definition of the schema, what is a schema? It's a description of your database. What we are going to do is we are going to describe our database, company database or university database using what? Relational model. Then they can be implemented by SQL. Okay, so not just describe, we need to translate our requirement description into the SQL. So using SQL, we are going to create our database. So first, we are going to create the schema. But not always you can create. You are going to create your schema. Not always. So the reason is that when you log on the SQL, MySQL, so do you remember the last time when after we create the MySQL database, we are going to use a root user. This root user is not the root user of operating system. It's not super user of the operating system. It's a database. Okay, database, the root user. Oracle uses different name of the root user. Oracle uses sys and system. Like that. Okay? So this root is not the root of operating system, it's a database user. So database has the database management system, has their own authentication, their own user and password. Okay? So at that time, if you do not create the explicit schema, username will be used for the schema. So if you create the user, then I do not create the schema, I just create the table and anything that's under schema automatically. So same thing, any other, the DBMS. So most of the case, one user per one schema. That's recommended in the real project. But if you are going to create a different schema means what? Different database. They are not related. Okay? Because of that reason, you'd better use one user and one schema, which means you don't have to create the schema, but in case you need to create the schema using the SQL. So, good news, most of the SQL, it's straightforward. You can understand the meaning of them. Okay? So syntax itself is very easy to understand. So like for example, create. Almost all the database object will be created by the create command syntax. So create is what? Reserved word. So you cannot use the create as the name of table, name of index, name of the reserve. And schema, you can create the schema company. So company schema will be created and give the authorization to J. Smith user. Okay? So sometimes one schema is authorized to multiple users. At that time, you can create the schema, then give the permission to the user. Many of the time, database user will be shared by the developer, okay? Or even the organization. If you have the one database, company database, university database, and payroll use the same database user. And the department use the same database. So this is the username. So you can give the authorization if you want. So this is the create the schema. This syntax shows the several things. First thing is you can see sometimes the capital letter, sometimes the small. This is capital. Sometimes the small. Okay, lower case letter and uppercase letter. So, question: database is case sensitive or not? Yes. Actually, no. Database, the SQL is not case sensitive. However, some of the DBMS, depending on the interpreter program, they require such a case sensitive. So, however, most of the case, people like the database engineer, database programmer, database architect, administrator, they like to use the reserved word as capital letter, uppercase letter. Okay? Then definitely between the single quotation or between the double quotation, this is the case sensitive. Okay? So as you can imagine, so J, the capital letter J Smith is the value. Okay, so that is just the general rule of the SQL. I'm going to skip this part. So then, if you are using for example, under the schema, if you have the employee inside. This one is actually Lee dot the employee. So not case sensitive, so LE or LEE dot employee is the same thing. Okay? So we can use the dot notation. However, we know the another dot notation, table relation dot attribute. So if you specify the attribute like the SSN, so Lee dot employee dot SSN means Lee schema, employee table, and the SSN attribute. Most of the case we don't specify this one. Why? Username. If you are using the Lee user, then automatically Lee will be used. However, if you are using another schema, then you need to specify with the proper permission. So that is the common rule of the SQL. So we are going to start with the data definition language. Data definition language is for what? Creating database. Creating data structure. Okay, so how can we create? You can imagine. How can you create the table? Create table. How can you create the index? Index. How do you create the index? Create index. How can you create a view? Create view. Very straightforward. So you can imagine. How can you remove the table? We are not using remove, instead the drop. When you create any the database object, we can create the reserved word. Then when you delete, remove, drop. When you modify, update, actually update will be used for another modifier. That's the data manipulation language. So we use alter. So if you modify the data definition language, DBM. If you modify the table, alter table. If you drop the table, drop table. If you create the table, create the table. So we are going to use the reserved word. So let's start with we are going to use this one is company database. So we are going to use the company database for the example. So we are going to start with you are going to practice. So please, you don't have to memorize, but create the table by yourself. Okay. My recommendation is first, if you have time, do not copy and paste. Probably you will have the mistake, like sometimes you forgot the blank space is mandatory. You need to separate the keyword or object name by the space, but this space is not required. So by typing, you can realize which one is required, which one is optional, and also you can see whether there is a space or the tab or whether this one can be one line. Any SQL command, data definition language, data manipulation language, it can be one line. Okay. However, for better understanding, we can wrap the text by the new line. So enter new line, new line, new line. So we need to know where is the end of the SQL statement. That is this one, semicolon. Keep in mind, semicolon specify where is the end of statement. Okay, not the end of the line, not the end of the line. So end of the statement is the semicolon. Okay. Okay. Always. So don't forget when you answer the question, or when you answer for the question in the exam or even the practice, this one is the end of. Sometimes, even though you missed this one, there's no error depending on the program, because they understand by checking the syntax, this might be the end of statement. They automatically add the semicolon. So don't forget, it's kind of a good habit to put such a semicolon. Then, when you create the table, I cannot give the full syntax, but the main idea of how to create the table. When you create the table, minimum requirement is the table name. Table name is required. Then at least one column name, attribute name. So if you have multiple, you can separate by the comma. So you can have the create table is the keyword and table name. You can give the table name. Table name is from your relational model, or you can change if you want. But that's it. Then parentheses. Between the parentheses, you can put the list of column, list of attribute here. Then, if you have multiple, mostly multiple, you can separate by the comma. And each attribute name. Attribute name and the data type. data type. So first time we have seen the data type. In relational model, what is it? Do you remember domain? So actually, the EF code proposes we can get the value from the domain. Then the Cartesian product of the such a value is the tuple. So this one should be domain, but do you remember? Domain is not easy to implement. For example, name. This one is the name. Name domain is how many possible names in English? Domain is a real example. Lee is in the domain. And James, Smith, even AAA can be named. So it's almost unlimited. We cannot keep all this, the domain in our database. It's too big to carry. Instead, the people think about, can we standardize what structure? So that structure is called the data type. Instead of the domain, name is character 30 maximum. This is the kind of a restriction. Instead of using domain, so we are going to use the data type. So this is the data type. So it's a good idea to see the possible data type. So database support the mostly numeric and character data type. Good news? So you can actually understand the most of them. Most of the generic the data type are supported, like the integer, int, integer, small integer, floating, definitely. The floating is important in the program language. Any program language, there are sometimes we can use a floating point as a performance to check the performance, because so character is a 1 byte, right? And the string is a sequence of the byte. But the number, integer, they can use the 4 byte or 8 byte. Double is a 8 byte, like that. But the floating is unlimited. We are going to use what? Exponent. Right? That has the kind of precision. So database also support, but the old version of database is not very precise. They have kind of the error, but nowadays it's a fixed, so we can use. All together, even you can use the number data type. No matter what value is in, automatically the assign the proper the data type. So you can use the number. How many digits? 10, comma 2. How many digits under decimal point? So which means this one allow 1.23 like this. So you can use the number instead of any of this. But because the developer mostly they are familiar with the integer, double, float, so you can use such a data type, the conventional data type, or you can use the number with the precision. Okay? And then character. That supports the character and what character, and this is the new one in database. So you can call the pronounce the variable character, or somebody pronounce varchar or var character. So different pronunciation. So variable character. So what's the difference? It's a fixed length and a variable length. The difference is, if you define the name as the character 10 byte, in an internal database, you remember the internal schema? Internal database, we don't have to worry about internal. But if you are developing the new DBMS, you should define how can we keep the character. So inside, we are going to allocate 10 byte. Even though we have the lead, 7 byte will not be used. It's a waste of a space. Like if I define the 10,000 character, but only 3, it's a waste. So to address that, there are variable length, variable character. It's a kind of maximum. N means maximum. So if you insert only 3 byte, LE. If you update the later S and add it, up to where? Up to, in case variable character 100, up to 100. Fine. This is a variable character. You can see variable character 2 sometime. Okay? The variable character 2 currently same as a variable character. But when I use the database, when I was the database administrator 20 years ago, variable, even 10 years ago, variable character and variable character are different. This is the short history. Oracle. First, when people standardized the SQL, they defined the variable character up to 2005. And the internal schema is not well organized, not efficient. Okay? So Oracle used their own define their own variable character and name it as a variable character 2. It's the support up to 4,000. It's much bigger, and their own data structure are different. But it was not standardized. But people like to use variable character 2. So because of the still, if you see the SQL statement, they are using variable character 2. Then, because of the popularity of this one, other DBMS use this one. So it looks like the variable character 2 is more popular than standard variable character. Later, I cannot remember 2000 or the 2006, the standardization group, they accept the variable character 2, then it's the same. So still you are able to use a variable character 2 instead of variable character. Old guy use the variable character 2 also. So that is a variable character. You can see some different bearing or it's not very popular, but it supports the long, the document style, it's almost binary style. Then the B string is a binary, like if to store the image. Okay, like that, the binary. And Boolean is support the Boolean true or false. One more thing, database has null. So null is not the true, null is not false. As I said, null is like a ghost. Somebody believe? True, somebody not believe. So we cannot say, so there are three values when you define the Boolean. True or false or the null. Another benefit of using database, the data type is the date. Date and time is frequently used. Anyone who know how to use the C language? C program. So what is the first most difficult part of C program language? Structure, pointer, right? To understand pointer. So because of that, the 90% of students give up. Then they turn into the C++. So when I learned the C language, there are no other options, so we need to use the pointer. It's okay, so we can use the pointer. However, so first, the most popular project or assignment for the C language is calculate the period, number of days between two. How can you do that? You can minus from the input, and first input and second input, but it's the days, number of days should be, you need to calculate the months. Months is different, especially leap year. Every 4 years, it's 29 for the February leap year. But every 100 is not, right? But every 400 is yes, like that. So that is a leap year. So because of that, it's not that simple. People complain a lot, and also one of the reasons to use a database is reporting. So they don't want to calculate such a thing. Instead, the database provides a date time. So that has a year, month, and day, and the time also. Hour, minute, second, the 100th the second level. You can calculate. Also, another benefit of using the database, the date type, is you can change the format. So somebody used the YYY MMDD, my country preferred this one. Here, MMDD and the YYY. Some even, this one was the problem, year 2000. Okay? So currently most of the system use a 4-digit per year, but this one can be DBMON also. So JAN. So depending on the locale, there the type are there different. So because of that, when you set up the operating system, even you need to specify the location of and what is the currency, what is the date type, and so on. But database you can always change. Internally, they are using the internal data structure for date. It requires 7 bytes, but for the explicitly you can change whatever you want. Then the timestamp, and there are a lot of the function to calculate the date and time, number of date and the period, which one is earlier, which one is not. So you can use such a thing. So domain is not actually implemented. Very rarely the database support the domain. At the time you can create the domain like that. Okay. And also data type. Because of the popularity of the object-oriented, so you can create your own data type. It's a user-defined data type. So like the GPA data type or something the UB student data type you can create, but not very popular. Okay, so this is the data type. Go back to this. So you can create the table with the data type, one of the data type. So data type is mandatory. So this is the simplest syntax. One, create the test table, one attribute, and there is the data type, then that's it, parentheses. And don't forget the semicolon. This is the simplest syntax to create the table. You can create the table with this without error. Okay, then the others are optional. Let's see the optional statement to create the table. So if you have any constraint, condition, like this is not null. So we have seen what is a non-null. If you specify D name and the D number is non-null, you can specify the constraint next to the data type. Okay? If you have a multiple, you can separate by the comma, except the last one. Some of the interpreter allow comma here, but you don't have to. This is the non-null. You can select any data type, variable character 10, integer. Instead of integer, you can use a number, character 9, so you are able to differentiate the variable character and character. Then this is the additional. So this is we are going to create the DPT and the parentheses. We can list up to here. But what about the primary key? So each relation, each table should have the primary key, one primary key. Primary key is like this one. Primary key after the last column, last attribute, comma, and add the primary key and the primary key. The column D number is the primary key. What if composite primary key? D name plus D number. Primary key, D number, comma, D name. Composite primary key is within one same parenthesis. I have candidate key. So do you remember the candidate key is the same as almost a primary key, but it's not selected. Primary key is only one. So this is a secondary key. Do I throw away the candidate key? You'd better keep it one because it's almost the same level. So which means we are able to use the D name to access the data. It's also very fast. It's a highway to go to the destination. So we can create the secondary key as a unique. However, difference between the primary key and unique means not null. Okay? But here, even we specify, if you do not have the non-null, automatically when you create the primary key, D number will be non-null automatically. But you'd better explicitly mention if you want. But this one, if you do not specify non-null, but if you create a unique key, there is no non-null constraint. That's the difference. Okay? Also, another thing, when you specify these two, what happens inside? How can you check the primary key? How can you check the unique key? You need to sort the data, right? Automatically, index will be created. Okay? automatically index will be created to keep the such a uniqueness. Then, if you have referential integrity key, foreign key, do you remember? Foreign key has the referential referenced. This one should be primary key. You need to check DNO is in the D number in department. It's a primary key. And this one is the reference. So, foreign key, when you create a foreign key, reference one. So, MGR SSN, this is a department. MGR SSN should be here. This one refer SSN in employee. So, this one is MGR SSN in DEPT and employee. This one is SSN, primary. Not always, but mostly it should be primary key because this one should be unique. So SSN. Then this one is the reference. Okay? Reference and reference. You can use the references. What? Which SSN? EMP SSN. Then you can run this one using interpreter. Question. When you run the DDF, there's no problem in terms of syntax. What happens when you create this one? When you create the DPT? It will be error. A lot of students encounter such an error when I direct study SQL, relational database, and run the first command. But it will be error because you do not have employee. Right? So when you create the table, you need to check which table will be created first. Which will be, because it requires the employee. So it's not a good idea when you create the first time with such a constraint. Later, you are able to add the constraint. How? Alter table, DPG, add the primary key. You can specify the primary key. After you create the table without constraint, okay? So it's an empty room, empty room, empty room. Then add a primary key. Add a primary key. That will be safer. Okay? Especially if you have the millions of data. What happens if you create this one? Whenever you insert the data, automatically calculate what? Index, whether unique or not. Primary key is okay or not. It takes a time. If you check the door, verify each and every student, it will take a time. Instead, you create the table without any constraint, which means empty row, put all the student. Then all together check the key. Okay? Inside. That will be faster. Right? One time, check. So it is suggested when you create the table really. So later, for practice you can do, but the example you can create the table without constraint. Then later, you can alter the table by adding such a constraint, like the primary key, unique, and foreign key. You are going to practice. Okay? So this one. What about the project? You can create a project like this. Okay, so this is the foreign key, and this is you can specify the multiple foreign key, and this is what? Composite primary key. Best way, type and see what's going on. So we haven't seen this and this. Sometimes except this part, all the others are optional. So I'm going to quickly go over the optional statement. So default value is if user does, when later user insert the data, if user does not specify the value, automatically default value will be assigned. Like for example, all of them are UB student, freshman. So instead of adding the freshman as a grade, so just empty, that automatically freshman will be added. In case of transfer student, the grade will be specified when you insert. At that time, you can use the default. Okay. And also there are, this one is some of the DBMS implementer, sometimes I'm going to skip. So this. The primary key, we have seen the primary key and the unique and the foreign key. So foreign key, don't be confused or raised which one is a reference, which one is a reference. However, they are interesting. So let's see this one. So one example is the manager. EPT, this is the employee. SSN, this is the T number, and MGR SSN. So this one is the foreign key. So we have the manager 111, definitely 111 is here, and the name is Lee, like this. What happened? I'm retired. So this one will be deleted. What happened is, it's a problem, right? It's a violation of the referential integrity. So we need to do something depending on your rule or policy. So first option is you can delete automatically. If the reference one, primary one is deleted, this the foreign key or the value referred to this one will be automatically deleted. Another option is, it's not fair to delete everything. Instead, we are going to assign the default value, like the 100. It's not real. The people is the kind of fake person. The reason is that if we delete this one, like the DNO is a 10, department 10 will be deleted. Even though the department manager is quit a job, we need to delete the entire department. We don't want, right? Instead, until new one is assigned, so we can replace the value by the fake value or default value. That should exist here. Okay? Or another person. So you need to select such an option with the foreign key. You can see the foreign key. DNO reference department D number on delete. On delete means if the D number is deleted, set default. We can use the default value. What is the default value? 1. You can use that default value. Or on update. Update means I'm changing the SSN name 112. Okay? What about this one? Automatically, cascadely update 112. Okay? So, cascade, on update, the cascade means following any associate, the value will be updated automatically. So you can see the option like the on delete, in case of delete, so set default. On update, cascade, like that. Okay? So you can specify the more details option for the foreign key. You can see some difference from the previous example. Previous example is like this. Where is the table? Yes, the primary key foreign key. This is more general, popular, but if you want to specify the name of primary key, oops, where is that? And later, for optimization purpose, I'd like to check the name of primary key. At that time, you can specify the constraint and your user-defined name. It's an optional. If you do not specify this constraint, the EMPPK, system generate the primary key name. It's like the ABC or the whatever. You cannot understand the meaning of that, but if you want to specify the name of the primary key, you can use. Same thing for the foreign key, you can specify. Same thing, alter. After you create the primary key without name, actually there is a name, system generate the name, but you can change the name using the alter table. Can you see the constraint? So, if you create a table without constraint, the system, database system generate the name like the A, B, C, 1, 2, 3, and random generate number. technique.
For the primary key.
So for primary key or foreign key. But if you want to specify this is the employee, the PK, like this, you can use a constraint and name and primary key. Okay, there's no comma here. This is one, the close. So the reason we need such a primary key name is later during the query optimization, we can specify please use this primary key. Okay? Using that primary key, you can efficiently access the data. Okay, later we will see. But you can specify the name in case you need. Or the foreign key, unique name, all of this, you can specify the name. Okay. And so after you create the table, so you are able to drop and alter table, you will practice during the exercise lab. And this one is the data manipulation. After you create the table, you can, first I'd like to introduce the insert data manipulation language. You can insert the data. So when you insert the data, insert into value is the keyword. You can understand the meaning of that. Insert into table name, value is the parenthesis. At this time, the order of the attribute is a set of attributes separated by the comma, 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 comma. And each one is the value of the attribute column. Then this order is the same order as the attribute of employee. What kind of order? When you create the table. So we learn the order of attribute, there's no meaning. However, in this case, there is a meaning. So if you do not specify the column name here, so this order should be the same order as the attribute when you create. Otherwise, you can specify the column name. This one is not the same order as this one. Instead, you can specify the column name and the value. But here, it's different from the value. Value is you can explicitly specify the value. Sometimes you can select from other table. And output ename, the lm, pname, hours should be type comparable. It's not the same type, type comparable. So character can be comparable with a variable character. Variable character is comparable with the character. The character will not be comparable with the number or date. But the date can be comparable with the character like that. So such the type comparability will be applied automatically. So this is an insert. Then also you can delete the data. When you delete, the rule is delete from where. So delete the employee condition. Where is the condition? All last name is Brown will be deleted. And same thing. Always don't forget end with semicolon. And delete. If you delete from the employee, all value will be deleted. So you will practice during the exercise what you did. However, one more thing. After you delete this one, not only delete, update, insert. What happened in the database? Actually, database will not delete until save. That is a commit. So commit is the command to confirm, to delete or change the data. However, sometimes after I delete or modify any the data, without commit, I exit the interpreter. That cannot guarantee. So depending on the option of the interpreter, some of the interpreter allow automatic commit, auto commit. Some one does not apply auto commit. It's a rollback. Rollback means it's not applied. It's the original one will be applied. We will discuss commit and rollback more during the transaction management later. Okay. So this is the delete and update. You can update the data. The keyword is update set. Set the new value. New value. Okay? So this is a new value. Value is a new value. Where is the condition? Not all of the update, the specific, the tuple. So you can apply this. Same thing, commit or rollback. This is kind of habit. Nowadays, more and more the tool automatic commit. But instead, you'd better apply the commit explicitly. So this is an update. Then, going back to here, so after we create the table, insert, update, delete the data, then we are able to select. So this is a very basic, as I mentioned a couple of times. Select from where is popular. However, select from is required. When you select the data, when you retrieve the data, select has the attribute list. Projection in terms of a relational algebra. From is the table name, relation name. That's it. That is the minimum requirement. However, if you want to specify the join condition or selection condition, you can use the where. If you want different order, you can use order by. What else? You can use the aggregate function. If you are using aggregate function, group by. Okay, and having. We will see the group by and having later. Okay, maybe next class. So go back to the selection. Okay. So first, we can use any logical operator in the where condition. It's already 12:17. So 3 minutes more. So we can use such a logical operation, and I suggested if you take a look at your textbook. Textbook has all these examples. It's also both relational algebra and SQL. First, I give the handout. If you do not have, you can pick up. So please try to solve the book and the shopping cart, the data definition language. Then, for your practice of the SQL, instead of typing, first think about what will be relational algebra. So for example, here, the retrieve the birth date and the address of employees whose name is John B. Smith. Do you remember? First, you need to decide relation name, table name. How many tables do we need to access? All information from employee. So employee. Then this is the condition, selection condition. So we can apply selection. Then finally projection. So you can have the relational algebra expression that will be easily converted to the select from where. Okay? So where condition. So then you need to follow the syntax of the select, like you can use a logical operator. It can be one line or you can change the line. It doesn't matter because it's an interpreter. And there is no comma. However, if you have the many attributes separated by comma, if you have many tables separated by comma, last one does not. Okay. So like the condition like this. So always when you start to learn the SQL, think about the relational algebra together. That will be much easier than if you have this kind of query. So for every project, we can Stafford, this project number and the controlling. So from here, if you identify the relation, that will be project, department, and employee. That's what we have seen before. And how many join operation? Join condition? In case of 3 table, 2. So 2 is a D number, and manager social security number and social security number. Then there is a selection. Selection condition is here. Then we need to project number, D number, name, address, and B date. So you can create the SQL through the relational algebra expression. So you are going to practice this one. While the DBM she's doing the exercise, she will explain more details of the select, the syntax. Then the pretty much basic SQL will be done. Next class, the Wednesday, we will have pretty much the entire exercise. Should be ready to MySQL prompt interpreter should be ready. Then you are going to create or something the practice. Then the next class on I'm going to I got the email from the just before. Let me quickly check. What is the answer? I got the email. There's no class Monday and Tuesday for graduate and undergraduate students. Okay, so we'll not have class this one. So because of that, I'm going to follow the changes schedule. Okay, so next class we will have an exercise lab, and no class next week Monday, and Wednesday we will have the database programming. Then week after Monday we will have the exercise lab for the database programming, and then we will have the midterm exam. Midterm exam, if you are going to prepare the midterm exam, 60% from this handout, online bookstore. But instead of online bookstore, I'm going to select one of your ER model, the example database. So first one is ER modeling, and the second question is the changing, converting to the relational schema diagram. Third one will be data definition language. Last one is a SQL and relational algebra. That's the 60 or 70%. The other will be multiple choice. So asking the sum of the concept of the relational database. So do you need more information about the midterm? I think first you need to study, because if you fail the ER diagram in the first question, consequently the last of them will be messed up. So you should practice from the ER diagram. So ER diagram should be correct or almost. It's very hard if you miss the first question. Then the other are correct based on the missed one. It's very hard to give the credit, really. So please practice with the example that I uploaded. Any other questions? So on Wednesday we are going to have the exercise.